So welcome back. Hopefully everybody had a good break, well rested, and you're back into it or whatever. So if you had fun, great. I had somewhat fun, but not as much as I should have had. Anyway, we're getting back into databases, and we're going to finish up with databases today, and then move on to JDBC, which is a way of programmatically connecting to your database. But we do have some, loose ends to cover. If you have any questions, you can go ahead and post the YouTube live stream here. I just wanted to bring your attention, though, to the fact that the Gantt chart only went up through the last phase, right? So there's spring break right there. If you were wanting to plan for this phase, right, and the next phase and the next phase after that, you got the first half of the course for free. Now you need to provide your own schedule, because that's part of the process, right? You now know how you've been working over this, how you've separated the tasks into subtasks and stuff like that. And so now you can fill out your own Gantt chart going forward if you've been using the Gantt chart. We will still, of course, have those pinned posts week to week on what you should be doing with respect to what would have been put into this Gantt chart. And you can follow along on that if you really want to. But otherwise, whatever you use to organize, keep it up. Let's see. All right, so last time we finished up with the design of this database right here, which was basically modeling our problem over here of a savings account, an annuity account, and the inheritance thereof, right? We've got these two accounts, an annuity account and a savings account. And then we changed it so that the ownership here was a many-to-many relationship, so that one person, of course, could have multiple accounts, but also that one account could actually have multiple owners, right? And so we're going to probably have to update our Java to get this done. But we also have this table over here to simulate emails, to model the fact that one person can have many emails over here. We separated that out into another table, and today we're going to find out why we did that, because that's basic first normal form. Now that we remember what we did, let's go ahead and come back over here to our notes and start enumerating what we did throughout that process. So first of all, naming convention should be consistent. Our suggestion is to use upper camel casing singular form for table names, lower camel casing singular form for columns, right? And to be consistent about it. Another naming convention here would be that make sure every table has a primary key, which should be an integer, not null, auto increment. Increment, there we go. And name it after the table. Right, so it should be table name plus ID. Right? Camel case like that, lower camel case like that. Why? Because it takes out the guesswork. If you have every single table having the same primary key naming convention, you never have to worry about that at all. Right? You can just look at the table, the person table, right? And I know immediately what the primary key of that table is. Make sure that foreign keys match the name of the table column they refer to. For example, over here in the email table, we have a foreign key called person ID that refers back to the person table's person ID. Same person ID. They match. Avoid using strings, right? Avoid using strings for primary keys and foreign keys, right? You have too many casing and encoding issues to deal with. Depending on how you created the database, what the database defaults are, how you're querying, what the collation is, et cetera, there's just too many variables that things can go wrong. Is that uppercase H hello equal to that lowercase h hello over there? No, I don't want it to be, but all those issues go out the window when you're comparing an integer to an integer, because an integer is an integer is an integer, and it ain't changing, okay? So just make sure that you're dealing with actual keys. Of course, you can have a secondary key to ensure uniqueness or something like that based on a string, but that should not be your primary key, and it should not be a foreign key, okay? Join tables can be used with multiple foreign keys to model a many-to-many relationship. Be sure to insert plenty of test data into each and every table. Right? In fact, that's going to be a requirement for your next phase here. But don't worry about it because it's super easy. Why? How did you generate your data for the first two phases, or the first phase? Yeah, the first and second phase, whatever, right? You went to, mockdata or .com or whatever we provided. And then to generate your XML or your JSON, we gave you another tool, CSVconverter.com or whatever, right? And it had output for JSON, it had output for XML. Guess what else that has output for? SQL, right? SQL insert statements. So it's really easy to generate a bunch of test data and make sure that it's inserted with every table. Don't make it hard on yourself, right? Make sure that you are defining uniqueness where necessary to enforce data integrity. If something is unique, like a social security number or an NUID, you need to put a constraint in there to make sure that it stays unique and so that nobody can insert additional data. You should also have good normal form. All right, have good normalization. And that's a topic in and of itself. There are many normal forms. We're going to talk about the original 3 from Edgar Cod. First normal form, second normal form, and third normal form. NF is short for normal form, right? First normal form is that each and every single attribute, and by the way, there is fourth normal form, fifth normal form. That gets into temporal databases, and that goes beyond the scope of this course. So we're only going to focus on those first 3. The first normal form is that each attribute in a table only has atomic values, right? In other words, each column in a table only holds one piece of data, i.e. one value, right? Not multiple, right? So it's easier to understand these things if you look at the violation of what violates these things. So one way of violating this would be storing multiple emails for a person in an email table, email column, and separating them using commas, right? In other words, CSV data in a RDBMS, DBMS. There we go. It kind of takes you back and defeats the entire purpose of doing a relational database management system to begin with, right? That if you've got multiple pieces of data, email, like you've got 5 emails or something, right? You don't put them into one big giant string and then delimit them by a comma. You put them into, if you're talking Java, what did we do? What is a person over here? Java person emails is a list of strings. You have a collection or an array or something like that if it's a different language. If you're in a database system, what does it look like? It's an entirely different table with a one-to-many relationship here. Right? That's good first normal form. Another violation would be if you just said, oh, well, 3 emails is good enough. Violation, storing emails in enumerated columns. For example, email 1, email 2, email 3, right? If you were coding in Java or say C, right? This is something that you might do in the first week because you don't know how to do arrays or lists yet, right? This is something a beginner would get out of the habit of really, really quickly in a regular programming language, right? So don't do it in a database either. Right? Now there are use cases in which this might be useful where, yeah, we're only going to support a primary email and a secondary email. We don't need an entire table to do that. We don't need to be writing a bunch of joins, et cetera, or we only want to support one email or something like that, right? Then you might have a cause to say, okay, well, then we won't create an email table. But if you have a one-to-many relationship where you need to support 0 emails, 1 email, or 50 emails, right? Then you need to make sure that it's normalized, okay? Simply define another table and model a one-to-many relationship. That's first normal form. Second normal form. It has to be first normal form and, quote, I'm going to cut and paste this because I don't like saying it, but we'll parse it out anyway. No non-prime attribute is dependent on a proper subset of prime attributes. All right, well, what does that mean? You can parse it out and try to understand it a little bit, but what the hint that I'll give you here is that if you've been following the instructions the entire time and following how we've been designing our tables, you get this for free automatically. Right? If you have a primary key that's automatically generated, it's non-null, that gets you a second normal form for free. Now, to understand what might be a violation of this, suppose we stored a customer ID and a store ID and a store address all in one table. Right? Observe that the store address, and that all in one table, and defined a primary key as the combination of customer ID and store ID. Right there. Usually, this only really happens when you've got combination, or there's a term for it, compound keys. If you've got a key that is actually the combination of 2 columns or 3 columns or 4 columns or something like that, this is where it gets you into trouble. That's why if you follow the instructions and only have primary keys, auto increment not null, you never even have this situation because you do not have primary keys that are combinations of 2 or more columns, right? The store address only depends on part of the primary key, right? And thus it's a violation of second normal form, right? And this is akin to breaking encapsulation in Java. Where does store stuff belong in Java? In the store class, right? Do you want to store the store address, right, in the person class? Does that make any sense? No. So it doesn't make any sense to do it in the database either. Store stuff belongs in that store table over there. Customer stuff belongs in that customer table over there, right? You relate them through a join table or through a many-to-one relationship, but you don't store everything in that one table. Separate stuff out into different tables, right? And you'll be fine, right? Often you do want to define a compound key, right? But it should almost never be a primary key, PK for short, right? We did this with our database. Remember over here, let's go over to the database, right, and zoom in here. Remember that we defined this constraint here, this uniqueness constraint on a person ID and an account ID. Right? Why did we do that? Because we wanted to model the fact that a person owns this account. Person ABC owns account 123. Do we want that repeated data? Do we want that person ABC owns account 123 and person ABC owns account 123 and person ABC owns account 123? Right? Do they own it 3 times? That doesn't make any sense. They own it once. And so the combination of these 2 values, we made that into a unique pair. Right? That is basically, you can also make that into a key. This basically does that, unique key. Right? You can also write it like that, and then it'll actually be a key, but otherwise that's just like it is, it's just a uniqueness constraint. Right? But you don't make that your primary key. A secondary key or a tertiary key or just a non-prime key, right? Third normal form does make sense, right? Third normal form is that it has to be 2 normal form, and therefore by transitivity, if you can go from A to B and you can go from B to C, you can go from A to C. How? By going to B first and then jumping over. Have you talked about transitivity yet in 235? Yep, okay. So transitivity here, 1 normal form because it has to be 2 normal form. So it builds on each other. If any of these building blocks fail, then it goes down to the lowest building block that actually, is there. Right? No non-prime column is transitively dependent on the key. So, for example, suppose you stored, for example, in our account system here. Right? Suppose you stored monthly payment, and and term years, and the total value into the account table. Oops, account table. I'm not sure what I just did there, but whatever. All right, let's go ahead and go over here to our Java implementation and zoom in on that. Annuity and savings account here. Actually, let's just jump into the account, the savings account over here. What is the value of a savings account? It's just its balance. But what is the value of an annuity account? It's the monthly payment times the number of terms times 12. Should we be storing this value that's derived from these three values in the database? Did we store that here in the annuity class? Did I store total value and then I made sure that that was monthly payment times term years times 12? No, right? Why? Because it's transitively dependent on these two values over here as well as 12, a scalar value, a constant value. It would be wrong to store that value over here in the table as well. Why? What if you changed monthly payment? Monthly payment was $100. Term years was 5. So 5 years, that's 60 months times 100, that's $6,000. I store $6,000 as well. Now the monthly payment changes. Now it's only $90. Is that $6,000 value still correct? Nope. So if I update one of these values, one of these two values, then I end up having to update a third value. That introduces the potential for data anomalies and bad data. Don't do that. Make sure that you're only storing data and not behavior. Right? Store only data, not behavior. Right? Derived data. Right? I spelled that right? Yeah, good. Right? So it would be wrong to store it would be a violation, not wrong is like an moral imperatively wrong, but it would be a violation of 3 normal form to store total value. All right, there we go. So here's a nice little mnemonic device that you can use to remember first, second, and third normal form. It's, come on. There. Every non-key attribute must provide a fact about the key, that's first normal form, the whole key, second normal form, and nothing but the key, third normal form, so help me God. Right? That's, you know, I swear to tell the truth, the whole truth, and nothing but the truth, so help me God, right? This is non-key, must provide a fact about the key, right? So it's not multiple pieces of data in one column. The whole key is not dependent on just part of the key, just the first part of the key. It's dependent on the whole key and nothing but the key, right? So this piece of data can be derived but from these two pieces of data, so this piece of data should not be stored over here, right? So help you Cod. Remember Edgar Cod? Right? From 1970, the inventor of the relational database management, or the relational database model, right? I'm not sure that he actually did SQL, he just came up with a model. Somebody else made SQL. Right? All right, so there's a lot that we didn't go over. There is a lot more, right, to learn about. This is not a DBA course, database administrator course. That would take, say, I don't know, I could put together like 3 courses with all of the stuff that I've heard about over the years on databases. Generally, if you take a database course, though, I think it's 413 here, you'll get into more theoretical stuff like how is stuff actually stored in a database? Is it paginated? Is it what data structures are you using, like B trees and stuff like that? How is an execution plan actually formulated by a database? We're only touching the tip of the iceberg here. There are other nice practical things. For example, triggers. A trigger is basically a rule that you can put into a database that says, when A happens, do B, right? So have you heard of it before? There's a website that allows non-programmers to do that. If what is it called? If this, then that. Is it? You know, it's just an if statement. If, then that, otherwise. If this, then that. There used to be a website that you could do this. Where you on social media, what you could do is you could define social media rules that if I post a tweet, right, then repost it on my Facebook or something like that. Or if somebody replies to a tweet, send me an email about that. You could set that up. If this, then that. ITT. Connect. Oh, okay. IFTT. Connect your apps. Not ITT Technical Institute, but if this, then, okay, we're having a lot of trouble today with various websites. Has anybody else been experiencing this? No? Okay. Anyway, you could set up this website where, you have a bunch of rules where if this happens, then trigger that thing over there. That's called a trigger, right? So if that column gets updated over there, then I want this column to be updated over here. It's a real temptation to use triggers to violate third normal form, right? If the monthly payment or if the term years gets updated, go ahead and update that third column where I am storing that total value to take this, and multiply 12, and then store it in the third column there. Don't do that, right? Triggers should be used very, very sparingly. But if you're a DBA, you might do them on a daily basis or something. You've got views, right? Which are read-only access to a table, series of tables, or part of a table. Right? Typically, you use a view if you want to grant read access to an application, but you don't trust that application enough to be making changes to your database. Inserting data, updating data, or deleting data. Right? If you have an app that is just going to display data to your user and you never want that app to actually remove data or change data or insert data, you give them a view. And that way you have an assurance that they can't screw up any of your data. Another use case of this would be, say that you've got a table with 5 columns and you want to grant access to the first 3. Name, first name, last name, and NUID. But that social security number over there, you don't want to grant them access. So you create a view with the first 3 and the first 3 only. Right? And then they can only see those first 3. It looks like a table, it acts like a table, but it ain't a table, it's a view. Right? Another thing that you can do with databases are stored procedures. Right? You can actually write full code, stored procedures. In SQL, do A, then do B, then do C. Now loop through that result set and do this thing, right? So you can write basically procedural code in stored procedures, and then you can call that stored procedure and repeat that code over and over and over again, just like defining a function. If you've got multiple steps to a process to produce a report or something, take those multiple steps, put it in a stored procedure, and then reuse that stored procedure. Again, it should be used very, very sparingly. Loops, variables, which are called cursors, etc. Right? So how can you define a loop? How can you define a variable? You can do that in SQL. Again, read about it at your local library. We're not going to get into it because it goes beyond the scope of what we're using a database for. For us, all this stuff is Yagni. You ain't going to need it for this course, but you should be aware that it is out there and that it is something that you can and maybe want to use eventually. Right? There's also security issues. Right? So, for example, don't store sensitive data in a database, unencrypted or unhashed. Right. So we took a look at this. Hopefully it's still up. Have I been pwned? There we go. Hopefully this is up and running. Yeah, it is. So you can go to haveibeenpwned.com and you can see whether or not you are part of any, and this is a newer email from me, and it's safe, and I'm not going to run it. I'm not going to run something that I've not run before I came to class on this. Let's see if I've been pwned before. Good news, no pwnage found. Right? The most common avenue of attack, even today, is to break into a system, break into a database system, steal as much information as you can. Well, if you've stored passwords in plain text, guess what? They can now gain access to every single user on that system. Now, if you have a little bit of, even just a little bit of security, you're not storing passwords, you're storing hashed passwords. Right? So, for example, SHA-3 online. What's the most common password, by the way? Password. So what happens is, come on. There we go. So let's go ahead and find out what the hash of password is. Right there, calculate that hash. There it is. Right? It's a very long hexadecimal string. Right? Now, if they were storing this as they were storing this encrypted like this or hashed like this in the database, I have access to this, but I don't have access to their original password. But if you use a common password like, say, password, or what's the second most common password? Password back. Oh, okay. I never even thought about that, but yeah. What's something even simpler though? Incorrect. Oh, incorrect. Well, guest is a common one, right? But 1, 2, 3, 4, 5, 6. Oh, it's got to be 8 characters long. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Right? There's the hash of that. All I need to do is pre-compute all the common hashes. Password 1, 2, 3, 4, password backwards, right? And all I have to do is pre-compute all these hashes and then see, does that hash match any of them that I pre-computed? Oh, you must have used the password, right? That's called a rainbow attack, and you can download these rainbow tables where there's pre-computed hashes all over the place. Or what else can you do? You can just use Google, right? And there it is, 1, 2, 3, 4, 5, 6, 7, 8. Google is one big giant, well, DuckDuckGo, I guess, is one big giant backwards hash-looking thing, right? Of the most common passwords that you've ever had. Question? You take the hash, you find out. Oh, by the way, why do we call it hashing? Does anybody know what hash is? So think hash browns, right? What are hash browns? Hash browns. We've got enough time. Let's look up an image. Yummy, yummy hash browns. They are potatoes, but how are they prepared? You hash them up. That's what's called hashing. Why do you think that we call it the hash mark? Hashed this way and hashed that way. It's been cut. That's what the hash mark is, the hash symbol, right? Hashtag or whatever, right? And so that's what hashing is. What you're doing is you're taking an infinite domain, the set of all possible passwords, and you're hashing it up into finite chunks, right? That's what hash functions do. It maps a large domain down to a small codomain. But what else do you do with hash browns? What do you do to make them even more yummy? Okay, well, yeah, there we go. You put on salt, or you put on ketchup, because ketchup's got lots of salt and sugar. No? Okay. Well, I put ketchup on everything, and hot sauce and everything. So I went to Canada over the break, and I went to kind of a dive restaurant and had a traditional pea bacon sandwich. Have you ever heard of that? It's just a big, huge, giant chunks of bacon that's been smothered with cornmeal, and then on a bun. Right? You eat that. And then what else do you order when you're in Canada? What's the most Canadian dish that you can think of? So what? Poutine, exactly. And that was the best poutine I've ever had. I've made poutine at home, but it didn't compare to this stuff. It was French fries with cheese curds and then brown gravy smothered all over it. And I asked the waitress, would it be sacrilege? Is it sacrilege in Canada to smother it in hot sauce and ketchup? I said no. So okay, bring on the hot sauce and the ketchup, right? And so you put sauces on. Why? Because it's salt, and you salt hash browns here, right? And so what is a salt? A salt would be something like this, where all right, fine, you're using a password, but I'm going to protect you from yourself a little bit. I'm going to go ahead and add on a random number. That's my salt, all right? So that when I calculate this hash and I try to look it up backwards, I'm not going to get any hits at all. Right? Because I used a salt. Yeah, you used a common password, but I'm helping you out a little bit here by adding a little bit of salt into it. You could also add pepper, and that's a global salt in a security system, right? But in any case, you never store just a plain old text password in the database. You can go ahead and store hashes, and they can steal hashes, and that's how have I been pwned before determines whether or not you've been pwned before. Right? It looks up and sees that you've had a hash stored somewhere, and I don't know. I meant to look. So who's our current chancellor? Outgoing chancellor? Ron Green. All right. Email. Let's see if he's been pwned. Right. There's the office of the chancellor. What's his email? There we go. Okay. Chancellor Green at unl.edu. Let's see if he's been pwned, and by whom. Oh, okay. No pwnage found. All right. I was hoping to get something, maybe potentially something embarrassing. No, probably not. All right, this is a UNL linked email, but you can look it up yourself and see if any of your hashed passwords have been broken into, and Then you can also, it'll also report whether or not the password has been broken by a rainbow attack, like we just tried to perform here on this hash. Right? So the takeaway there is do not store sensitive data in a database. And if you're going to store it, then make sure that you're storing it hashed, right? In general, don't roll your own, right? So don't roll your own security. Don't roll your own login. When you go to a website nowadays, does it force you to create a brand new account with a brand new password, or does it give you some options? For example, like if I went to, I'm not on Etsy, so if I went to Etsy.com, right, and I wanted to sign in here, what are some options there? Google, Facebook, or Apple. In other words, let one of the big boys handle this stuff, right? I'm not even going to handle security at all, right? I'm not going to roll my own. I'm just going to go ahead and connect into one of them. That way, password management, changing passwords, identity management, that's all taken care of by Google, free of charge, right? Now, if Google ever breaks and somebody breaks into Google, then everybody that uses that is kind of screwed, but that's CYA. I've covered my ass, right? That's what CYA is, right? Now, don't sue me, sue Google, right? They've got the big bucks. Don't sue me. Right? All right, so don't roll your own. Another option is you can do what are called soft versus hard deletes. Right? Security is really hard to get it right. Don't try it. All right? In a real system, you can go ahead and try it like in a toy system or something like that, but don't try it in a real system. A hard delete is when you use the delete query to remove data. No undo, no recycle bin, etc. Right? It's gone. It's gone forever. You can always go back to a backup or something like that. But otherwise, what you can do is instead you can use a soft delete, where a column you add an is active column to a table, right? And that you set to true or false, so that when somebody deletes a record, they don't actually delete the record. Instead, you set that is active to false. And so any query will only pull out, to pull out data to display data, you only pull out data where is active is equal to true. And you ignore all that other data. So that when somebody comes along and says, I think we talked about this before, but when somebody comes along and says, you know what, I accidentally deleted that stuff. Can you help me out here? That's going to take a long time. It's going to take a lot of effort here. It's going to take a lot of overtime, right? And if you're a consultant, we'll bill you a minimum of 5 hours for that, right? And all you have to do is go in and set is active to true again. And that restores all the data because it was never deleted, right? And that's what's called a soft delete. And then you're the hero. Or if you're a consultant and you're charging $200 by the hour, that just cost them $1,000, right? Yay. Yay for you, right? Otherwise, if you're not a consultant, then you just demand a raise or a pat on the back or something like that. All right. OOP versus the relational model. We've already talked about this, so I won't go. I'll go over it really quick. There we go. OOP models allow inheritance, right? But the relational database management systems, or the relational data model, predates inheritance by at least 10, 15 years. So you need a way to resolve the differences between these two models. One way is that you can create a table per class. That gets kind of unwieldy. You can create a table per stub class. So for example, over here, we could have created, let me go ahead and go with account, annuity, and savings, right? You could have created 3 tables, one for each one of these classes. You could have created 2 tables, one for annuity and one for savings, right? And then forget about that super class. Or what we did is you can do a single table inheritance strategy, where you have one table that models all of the classes all at once. One table for all of its subtypes, and a discriminator column, like we had over here, type, that tells you whether or not this is a savings account, S, or it's an annuity account, A. Right? And then you use a string to discriminate between those two types, and then some columns might be relevant for one type and irrelevant for other types, and vice versa. For example, for an annuity account, these first two will be defined, but these second two will be null. For a savings account, a balance and an APR are defined, and then the other two are null. You just put everything into one table, right? Don't worry about it. Okay? All right. So any questions on that so far? Again, there's a lot more that we could go over, but it's just one module in your CS2 course. Right? Go ahead and take another full database course or an online database course or something like that to learn a lot more. Right? Good? Okay. Oh, another thing that I usually forget, but I should have put down here. I'm going to put it in the notes so that I have it next year. Temp tables. Right? Temp tables are temporary tables. Temporary tables. Right? Where you can create a temp table. I'll query it out of that table, query it out of that table, query it out of that table, and then put it into another table so that I can query out of that one to make my queries a little bit more, easy. Or I can aggregate data, and then that's a new table. I'm just putting it into a temporary table, not a real table, but a temporary table to facilitate that idea. But we used to use those all the time in industry for a very, very, if you had a query that was like 100 lines of query code, what you could do is you could break that up into putting it into one temp table and then another temp table and then bringing it all together at the end. You could simplify this query, this 100-line query, down into a series of queries, and then have a very simple query at the end. Right? But temp tables allow you to do something like that. Did anybody check to see if they're pwned? What? Oh, what was the Gemini thing? What is Gemini, a Bitcoin? It's a Bitcoin exchange. I don't know. I don't know. Do I have any other famous person that I want to pick on? No, I don't know. Not that I know their emails, but anyway. All right. So you could find somebody. You could probably run my email like I just did and find out what if I've ever been pwned. But you can run anybody's email on it, and then you can check it to see what hashes have been found. Right? You can actually find rainbow tables online. Tables online. Yep. Online password cracking. There we go. With full rainbow tables that you can just download, or you can go ahead and just use them as a website. Non-salted hashes. Do I have? Nope. So what was the hash that I had? I don't know. There's no way. Oh, okay. I've got to do CAPTCHA. Forget it. Never mind. Yeah, somebody presented this weekend on using CAPTCHA or using ChatGPT to fool CAPTCHA, and all you have to do is ask ChatGPT, fool that CAPTCHA over there for me or something. Right. Say what? I have no idea. They were just talking about it. It wasn't a live demo or anything like that, right? But anyway, what we're going to look at now is programmatic database access. In other words, what we're going to want is we want to be able to connect to a database and process data programmatically. In other words, i.e. Java, or if you're using Java, or if you're Pythoner, then you're using Python. If you're using C, you want to use C or whatever programming language you're using, you can connect to a database, pull data, insert data, process data, do anything that you want. Up to this point, we've been using a full IDE to do that, right? We created a bunch of tables. I executed this script, but the data stays in MySQL Workbench. I'm interacting with it. I'm executing a command, and I'm getting stuff back, and I'm looking at it. This is all a manual process. That's not the purpose of this data. The purpose of this data is to be able to write a program that processes that data automatically, right, without human intervention. And so that's what we're going to be doing now. You typically use a database connectivity API. That's an application programmer interface. In other words, that API is going to provide you with a bunch of functionality, functions, classes, and other representations that you can use to generically connect to any database that you want, right? The API is generally generic, right? And does not connect to a particular database, right? In other words, MySQL versus MariaDB versus what are some other database management systems people are familiar with? How do we pronounce that? Microsoft SQL, right? If you're a Microsofter, right? SQL Server, or IBM Informix, or Postgres. And I'm tired of PostgreSQL. I'm tired of naming things, so I'm not going to, right? In other words, we want to write one set of code to generically connect to a database, and so that we don't have to worry about, well, how does MySQL do it? How does Postgres do it? How does Microsoft do it? We're not going to answer those questions. Instead, we're going to use, remember what's called dependency inversion, right? In practice. Do you remember the SOLID principles? SOLID, single responsibility principle, open-close principle, Liskov substitution principle, SOLID, interface segregation principle, and then the D is dependency inversion. In other words, we don't write code to connect to a MySQL database. We write code to connect to an API. That API is responsible for connecting to a MySQL database, or that API is responsible for connecting to Informix. Right? We're going to write one set of code so that we can connect to any database. Now, what we need in between is that implementation, and that's where connector J comes in. Right? So if you just do a search for connector J, it's a MySQL product that's been put out. All it is a jar file. Right? So select your operating system. Just go ahead and select platform independent here. Yeah, go ahead and download either a zip or a tarball. Let's go ahead and download the zip file here. Don't sign up. Just say no thanks. Start my download. Right? And if it works, we should end up with something that looks like this. All right, if I open up that zip file, I'm going to see that there's this jar file there. MySQL connector. This is 8.0.16. That's the current version. Right? Now over here in my Java project, I've got a lib folder, just like you already have a lib folder to store a bunch of jar files. You know how to do this already. Copy, or drag, drop, copy files, yay. Right click, build path, add to build path. Now you are set up to connect to a database. How do we go about connecting to a database? Right? So I'm going to go ahead and create a demo. I'm going to go ahead and start with a demo here first. Okay. I'm just going to get you started. For that, I want this over here. All right. Let's go ahead and connect to the database and pull all person records. Pull and print all person records, ... That's my purpose here. Well, first of all, to connect to a database, you need a couple of things. Over here in MySQL Workbench, what did you use? What did you need to connect using MySQL Workbench? You needed a host, you needed a username, and you needed a password. So I'm going to need those three things over here in Java. String URL equals, right? String username equals, and it's going to be me. I'm going to use my account here. And string password. You almost got me. I don't remember what it is. I'm going to have to look it up. Well, actually, I'm probably going to have to reset it. Right? So I'm going to go ahead and put in question mark here. Right? So where are we going to be connecting to? We're going to be connecting to csc.unl.edu/cbert. Right? That's the host that you used, and then there's the database that we used, or that we're going to define. Unfortunately, you need a lot more. You need, come on. Just a second, bear with me, because it's really long. There we go. You need something that looks like this. And that's just for compatibility reasons. So here's the protocol. It's not HTTPS because that would be Hypertext Transfer Protocol, secure. The protocol here is JDBC, Java Database Connectivity API, and MySQL. We're going to connect to cse.unl.edu. Don't worry about typing this out, by the way. We'll provide it for you. You're going to connect to your database, so change that to your database. You're going to use Unicode. You're going to use a compliant time zone shift because of the weird configuration that CSE has. Use legacy date time code, false, and server time zone is going to be UTC. Does anybody know what UTC stands for? Universal Time Code? It's Greenwich Mean Time, all right? But it's UTC. What is Universal Time Code? What is it? Coordinated Universal Time. There we go. And you know it's French or you know it's European because it doesn't match. Coordinated Universal Time coordinated, right? So that happens with French stuff all the time. And having just been in Toronto, I was keenly aware of all the English and French signs everywhere, right? And about every, I don't know, fifth person in the street speaking in French at very, very high volumes, right? So yes, it's a very European thing to change things around. Anyway, not to disparage any Quebecians or anything, right? Anyway, there's my URL, my username, and my password, right? I need a connection, right? So guess what? JDBC has a class called connection. And I'm going to go ahead and shorten this to con is equal to null. Now I'm going to go ahead and make this connection. Where is it stored? Let me go ahead and bring it in import. Everything for SQL is going to be stored in java.sql. Who would have thought? Right? There's the connection class that represents a connection to your database. Now let's go ahead and open a connection. Con is equal to driver manager dot get connection. And here we're going to provide the URL, the username, and the password. There we go. And upon success, assuming that your username and your password and everything is correct, that should return a brand new connection. The compiler is complaining about this right now. Why? Let's find out. When I hover over this, you'll find that everything that you use in the JDBC library throws an explicit checked exception for of type, what is it, SQL exception. So let me go ahead and surround that with a try catch. This is just a quirk of their being the Java folks from 23 years ago, their obsession with checked exceptions, right? Again, remember that that's a feature that no other language has adopted at all in the intervening 20, 25 years, right? But way back then, they thought it was the bee's knees, so they put it everywhere, right? And as a consequence, you're going to have to surround everything with a try catch. What do you do if you can't get your connection? If your internet is down, if you have the wrong password like I have right here, can you reasonably recover from that? Probably not. So what do? We throw a new runtime exception, right? We're anglers now. We catch and release. I rethrow that that runtime exception, that checked exception, as an unchecked exception. Let me go ahead and run this and show you that it will throw this exception because that is not my password, but it will connect. Right? Access denied for user because it's a bad password. Right? And that's where I'll end it today because I don't remember the password. I'm going to have to look that up. But remember, this is why we told you, don't use passwords that you care about. Right? Use passwords that you're going to share with your partner, that TAs and myself will be able to see because they are stored plain text in a Java source file somewhere. So don't use a password you care about. Okay? All right, next time.